do binomial expansion. So the most general way to write a binomial to raise to a power is, well, a plus b, quantity to the n, would then be, well, if you take a look carefully at what's going on here, you'll see that the first term, that is a, right, is being raised to the nth power, to the n minus 1, to the n minus 2, and then this means we're skipping a bit, all the way to the 0th. Think of that like our highest power of x all the way down to the constant term. Commensurately, the b is doing the exact same thing, but in reverse. It's starting at 0 and counting up. N minus 1 and then n. And this is kind of important because it's a very, very useful thing, if you add the two exponents together, you always get n minus 1 plus 1, n minus 2 plus 2, 1 plus n minus 1. You always get n, that is what the power that you're raising the binomial to. Now this c, that stands for a combination, so it also can be written like this. N, that is the power, choose, in this case, 0. So that would be n choose 0. And that first number of ways to multiply, that's what that represents. The number of ways to multiply is always going to be 1. If you think about Pascal's triangle, it always starts at 1. As a matter of fact, it always ends at 1, 2. N choose n. That is, pick n things from n objects. There's only one way to do it. And then it carries on just like this. Now, this is written as combinations, either nc0 or n choose 0, n choose 1, or nc1, right? Or you can use Pascal's triangle. We're actually going to be using Pascal's triangle. You'll see it's a pretty straightforward operation. So, let's do some examples. First, 2x plus 1 quantity to the 5th. So I'm going to do this out in a couple of different ways. I'm going to be very systematic about it. First, I'm going to move this out down a little bit. Now, I happen to know that I'm going to end up with 6 terms. 6 terms. Remember, the number of terms is always 1 higher than the power. So I'm going to have something plus something plus something plus, you get the idea. Now, what are each of these things going to be? Well, let's go in sequence. 2x plus 1 quantity to the 5th. To the 5th power means we're looking at the 5th row. That is, this counts the number of ways to get the different powers. So that means we're going to do 1 times, 5 times, 10 times. All I'm doing is working through these rows. Now what comes next? I'm taking 2x and I'm multiplying it by itself or by 1 over and over again, right? So each of these is going to have a 2x This is going to get crowded, so bear with me. 2x, let's move you over, Mr. 10. There you go. And we're going to have another 2x and another 2x. And it's going to be raised first to the 5th and then all the way down to 0. I'll do that in just, well, you know what, we can do that right now. So to the 5th, to the 4th, to the 3rd. How do you know you've done this correctly? If you had managed to hit 0, it means you've written out enough terms and everything. Let's go with blue. But that positive 1 is also being raised to various powers. But remember, the sequencing is always the reverse of the first term, which in this case are 2x. Or another way to look at it, 5 plus what is 5? 0. Then it counts up. Now, if you're thinking about this carefully, you're thinking, why is he bothering to write 1 to the 5th, 1 to the 4th? It's all just 1. You're right, it does make our job easier, because now we actually have to simplify and write this out. So, looking at this first term, we've got 1 times 1 to the 0, so that's just a 1 and a 1. But we have 2x, and please notice the parentheses. Not only is the x being raised to the 5th power, because we know we're going to have an x to the 5th term, but the 2 is being raised to the 5th as well. And 2 to the 5th is 32. Plus, well, that's a 5, so we have a 5 there, times, that's just a 1. But then we have 2 to the 4th. 2 to the 4th is 16. 5 times 16 is 80. And that would be our x to the fourth term. If you want, hey, we could skip straight to x cubed plus x squared plus x plus, and then this last one's just going to be a number. 10, what is 2 cubed? 2 cubed is 8. 8 times 10 is our friend 80 again. 10 times 2 squared. 2 squared is 4 times 10 is 40. 2 to the first, that's just 2 times 10. Well, that's just 10. And then last, 2 to the 0. Oh, that's 1. In fact, this whole thing is 1. So please note, after you've done your expansion, so this would be the full expansion, right there, that these numbers in Pascal's triangle tell you the number of times those particular terms appear. They are not necessarily the coefficients. Let's do another example, and it gets easier as you go along. Okay? Now, in this case, our other example, and let's move you down, we're going to be looking actually at the fourth row because we're raising it to the fourth power. But I'm going to create a little bit more space for myself here. We're raising 3x minus 1 to the fourth. Now, until you get the hang of this, I strongly recommend that you just write out your spaces, leave yourself plenty of space to write so you don't get too crowded. In this case, I'm going to write out, well, 4 plus 1 is 5, 5 spaces. And I know that I'm going to have, well, the numbers represented in Pascal's triangle, so 1, 4, 6, 4, and 1, because I'm raising it to the fourth power, so I use the fourth row. And then I'm also going to have my, well, I'm going to have 3x, and the parentheses are important because you have to remember that in this case, not just the 3, but the x is being raised to the different powers also. Or I should say, not just the x, but also the 3. That's usually where, if things are going to go wrong, that's where they go wrong. And then last 3x to the 0. And, of course, now this is where it gets a little tricky, that is a minus 1, which is also known as plus a negative 1, which means I'm going to have negative 1, and it's going to be raised to different powers. Now, if you remember from an earlier video, we said, hey, if we're subtracting, it causes these things to alternate signs. And sure enough, well, you'll see. There's certain things you have to remember. At least it's a negative 1, which makes the calculation pretty easy. So now, you know that you're going to have an x to the fourth term, a number, a coefficient, an x to the third, an x squared, and an x, and then just a plain old numeric term, and that'd be your full expansion. So now it's just a matter of doing this out. Now anything to the 0th is 1, so negative 1 to the 0 is 1, times, well, 3 to the 4th. 3 times 3 is 9, times 3 is 27, times 3 is 81. So this is 81x to the 4th. 3 cubed is 27, times 4 works out to be 108. Now, I just made a mistake. Negative 1 to the first. Anything to the first is itself. So this should not be plus, it should be minus. Now actually, if you wanted to, at this point, you could say, okay, well, we know it's going to alternate because of the negative. Positive, negative, positive. That means this has got to be negative. Now I'm going to go ahead and change it, and we'll make sure, of course, when we get there, but I strongly suspect I'm actually right, believe it or not. Okay, so keeping going. Where did we leave off? First term, second term, third term. 3 squared is 9, times 6 is 54. Next term. 3 to the first is 3, times 4 is 12. And, well, wait a second. Negative 1 squared was positive. That's a positive. Negative 1 cubed. Anytime a negative is raised to an odd power, it stays negative. And last but not least, negative 1 to the fourth. Well, that's a positive 1. Anything to the 0th, just 1, 1. And that would be, folks, our final answer. Please note, because of the negative, the signs did alternate. And so once you figure out which one's positive or negative, right? So if this was an odd power, this might end up being starting off, and it depends on where the signs are. So once you got the first couple and you got the pattern, then you can just alternate. Let's do another 2 examples, and then we'll be done. What if someone asked you to find the coefficient of the x cubed term in the expansion of x minus 4 to the 6th? Well, what we're going to do is this. We know if it's the x cubed term, right, that means we're taking x and we're raising it to the third power. So that's going to be the term. We'll talk about where in the Pascals. Oh, it's to the sixth. So that means we're going to be looking this row, right? Now, a couple of things are going on here. Whoa, that took a little bit of a strange turn. But it does mean that we're going to be looking at a couple of different things. First off, that is a minus 4, which so we know there's going to be a minus 4. And we actually know what power it's going to be raised to. Because remember, these powers, this plus this, have to equal 6. 3 plus what is 6? Well, 3. Now the hard part is, where are we going to end up here? There's a couple different ways to do this. What is counting? So we start at, this is our 0, 1, 2, 3. So should it be 20? Well, would that make sense? X to the 6th, 5th, 4th, 3rd. So indeed 20. Okay? Now, the coefficient. We know this is the x cubed term. Our answer is actually just this number. Well, what is this number? Well, this is negative 4 to the 3rd. Negative 4 times negative 4 is positive. 16 times a negative 4 is negative 64 times 20. Uh-oh. So let's try that out. We can break our calculator out for this one. 1280, see, it's good, but it's going to be negative. Negative 1280. So the answer, the coefficient, right, in this case would be just the negative 1280. Negative is kind of important. Okay? Let's take a look. Last one. Find the coefficient of the b to the 4th term in the expression 2a plus 3b to the 7th. Okay. 7th means we're way down here. So we know that this is, well, take a look. B. B is the second term. So we know we're going to have a 2a being raised to a power, a 3b being raised to a power. In fact, we know that 3b is going to have to be raised to the 4th. How do we know? Because this is the b to the 4th term. Now, what do we know about this? Well, we know 3 plus 4 is 7 because these have to, when they add them up, get to 7. So this will tell us most of what we're looking for. Now, if you look carefully, I'm going to have an a cubed, and I'm going to have a b to the 4th. Those are going to be my variables, right? What is the coefficient? It's always just the number in front. So I'm really concerned about all the rest of this. So I'm going to have a 2 cubed, I'm going to have a 3 to the 4th, but I'm also going to have however many ways there are of multiplying to get that. So how does this work? Well, if we think about this, it's 0, 1, 2, 3, 4. That is actually this power here, so the second term. So 1, 0, 1, 2, 3, 4 would mean 35. Or highest power, a to the 7th, a to the 6th, a to the 5th, a to the 4th, a to the 3rd, which is why I'm picking my 35 there. Now, I would strongly recommend a calculator at this point. 2 cubed is 8 times 3 to the 4th, we figured out before, is 81 times 35 is 22,680. Now, there are no negatives, so we can just write 22,680. So our final answer is indeed just that, the 22,680. And that concludes, or this concludes, our examples.